Okay.
That's great. So
Then let's do this one into range.
it's not okay. Yeah, let's do that one now. Okay. Now,
But
do
we
you have
different
any
column.
range? Do you have any range in mind you want to do it? Or we should do age? We did age yesterday, right? But you have any range for maybe the way they range, because there's a way they range it. Let's do age. Then there's something I want you to do with this one. We're going to have a cutoff. You do other operation on those other ones.
I have to convert this first now.
What do you say?
I have to convert this first and variable.
Okay, thank you. Yes. Go to variable. Variable view. Now change string, all the string to numeric. Change the string for sex. No, it's not. You are not doing it for sex. Change to numeric. Yes.
No, we did age, sex, and marital
Yes.
status.
Yes.
Skin lesion.
You did it now. You did it now. Yes or no? You forgot it. Go and check it.
Skin lesion.
Yes, that's what you yes. Yes, one. No, two. You forgot it.
Okay.
Go and check it.
That's true. No, you are correct.
So you can now give their value now. Yes, the sex male, female. Okay, this one single, the way you did it.
It's divorced now. DE. Was it DI?
The divorce. Divorce.
That's DI.
I think DI. Yes, DI.
No. Separated
yes,
before divorce.
And separator is 3. Divorce is 4.
Hold on.
Yeah.
Then sex. Female 1.
1, yes.
Moses.
It's not connected yet, too.
Okay. Done.
Okay, that's great. Now, delete that number 8 is the artifact. You have to click on it. Click on it, not right click. Right click. Right click there and clear. Okay, go and save now as SPSS so that can go save as It will take you to where you pick it. Yes.
I
Just
know. I know.
put in the name. Save.
Joe, let me just take this call, I beg.
No problem.
It's about the area. Hello, uncle? Fine. No. He hasn't communicated anything to me yet. Okay, let me call him this night. I'll call him this night and send something to you this night. No. No, I'll call him.
Okay. Save as you have saved it, right? Hello? Hello, Dr. Judith. I was in a workshop. I was calling you earlier on to find out that hope you are able to make effort to join. I don't know why you didn't join again. No. Okay, but I sent you the video. I don't even want to ask you. Did you receive?
Okay, let's go on.
Hold on, just 1 minute.
Let's go on.
Okay, no problem. We'll talk later. I'm seeing another meeting, sir. I'm just okay. No, we are even doing strategic plan. Okay, later we'll talk later tomorrow. Okay, thank you. Okay, Chief. Let's now do that this thing. Let's go to transform now. Transform. We want to range that age. Then you didn't just log out.
Network. Juro.
I'm listening. I said that
Hello?
you log. I can hear you. I can hear you.
Network.
Am I muted?
Network, gbé mi jáde.
Hey, I see that. The network is so bad.
Alpha.
Hello?
Don't worry.
Hello?
No, I'm you.
Yes, I know. You are trying to share with the yes, okay, that's share now. Okay, so we want to be able to range that age instead of want to have age group. So just go to transform. If you have quantitative variable, you want to divide into more than 2 categories, you go to transform. If it is 2 categories, I will tell you what to do. But this one is more than 2 categories, you want to range it to.
Okay.
So, you know, you go to recode to different variable. Recode to different variable down. Recode to different variable. This one. This one recode to different. It's up. It's up.
Okay, code.
Recode to different variable.
Okay. Okay.
Recode into different variable. Look at it. Now click on it. You know there is code to the same variable. That one, if you click on it, it will do it for you and delete the original one you have. Which is not good.
I know. It will replace what you have.
Exactly. I don't know why they put that option self. So then you move age. It's age that you want to recode. If you look at the icon, say input to output variable. So click on age and move it as the input. Then the output variable now, you type age group on other name. Age group. Click on change. Maybe click on it and display that question mark with it. Now click on old and new. Old and new. Old and new. Now click on range. Range. Down. Range.
Okay.
Immediately to highlight that something. So you can start from 0 since there is no age that can less than 0. It's just for you to capture the smallest. The smallest age here is 18. You want to choose less than 20 now. We'll put 19 as 0 to 19. 19.
Okay, 0 to 19.
It's 19, you write there, exactly. Now click on value. Type 1 under that value. Value on the upper right side. Type 1. Immediately you type 1. This add is a letter here. You add this, you go back. Say 20 to 29. You type 2 and add.
No, why no?
What is it saying?
Go back.
You type to 20 to 29. Why won't you type? Maybe you type something else. 2. Add. 40 to 49. 30 to 39. 30 to 39. That would be 3. 40 to 49. That would be 4. So 50 to 59 is the last one. Because the highest is 56 there. 50 to 59. I play 50 to 59.
Okay, continue.
Continue. Okay. Click OK.
Oh, the output sheet, what?
Yeah, thank you. So you want to label it, let's label it before you go and run it, because if you do like that, by the time you save it, after a while you may even forget what you coded as 3 or 4, whatever. So it's good, go to variable view now, so that you will not forget.
I close this one a bit.
No, don't close it. Click on variable view. No, you are in data view. Click on variable view.
Okay.
You will see there, 0 at the age group. Remove the decimal to 0. Reduce the decimal to 0 because it's making it untidy. Then you now under value. Now put the value of the code under value. And 1, what 1 means. One means less than is less than 20. 1 means less than 20. No, you don't need to put that. You say less than 20. Add.
Oh.
Less than. No, you can use the sign now. It doesn't matter. Use the sign.
Okay.
Just less than. Just less than. Add. 2 mean 20 to 29.
Dash up.
Yeah, dash. Just to take. What is under value? Then that will be 2. Uh-huh. 3 mean 30 to 39. Four mean 40 to 49. 5 mean greater than or equal to 50. You can put sign greater than or equal to, but it mean usually you can go to Word document and inside the sign in the Word document and copy and paste there. That's what I usually do. But you can put greater than or equal to yes, 2 of them, 50. That's good. So okay. If you go to data view now, go to data view, you'll see it.
Oh, has already done it.
Yes, now it has. Yes, it has done it. But if you want to see, it, go to view. If you want to see the way it is, go to view. You will see it. Click on view. Click on value label. Value label. Can you see?
This is excellent. I thought I was
so,
going to go and start adding it.
Yeah. So so if you look at it, all the label of female also the voice is showing you. But most of the time, it look right. People don't like it. So you can go and off it. There is there. So when you run the analysis, it will bring the name out. Sorry. Now we have done that. So you can another thing you can do. Let's pick that viral low or CD forecast. Let's divide them into 2 instead of ranging like this. If you want to divide quantitative variable just to 2 categories. You understand that? Let's say they say CD forecast that is less than 200. Less than 200 is not good. Low, that is a low CD forecast. So less than 200. So if you want to do that, you now go to data. That one, because you are dividing for more than, you can divide it into 2 with the transform with it, but it's a long process and it doesn't even, it's a waste of time. So the best is to go to data, then click on select cases, second to the last option there. It's the second to the last, select cases.
Okay.
Now, by default, you see all cases. That's what is by default there. Click on if condition is satisfied. Click on if condition is satisfied. Immediately you click, you see if under we highlight. Can you see it highlighted? Then click on that if.
Yeah.
Click on that if. It will give you this. Now move that city forecast, move it inside. Now less than, look for sign of less than. Type 200 there. You can type with your keyboard, yes, 200. So continue.
Okay.
Okay, click OK. The module I give you, all those things they are there also. So if you look at it, you see what he did. There's this filter, the last one. That's what he did is it has selected all those that have CD forecast less than 200 and mark them as 1. The one that have 200 and above, he marked them as 0. The one he didn't select, he marked them as 0. The one is selected, they are the one marked as 1. But if you look at the side, on the side of the bar there, on the left side, the one is selected, he didn't cross there. The one in the put 0 that he didn't select, he crossed them out. Do you get the picture now?
Yes.
So this operation you have done now is used to achieve 2 purposes. The first purpose is that, let's say now you want to do some analysis. You want to include only those people that have CD4 count less than 200. You can go out and run it. If you run it now, it's only the analysis will be whatever analysis you want to do. Either you want to do age, you want to do anything, you want to run analysis for sex, it's only the people that have CD4 count less than 200 that are selected for the operation. I don't know if you understand me now.
Yes. What is a filter?
What is it?
What are the filter?
Thank you. That's what, even there is a filter. It filter you for you, the one that are less than 200 CD4 count. It filter out the other one. So now that is one. So you can begin to run the operation until you don't want it, then you go back and change. But now, the second purpose is what we want to use it for. Because go to your data variable view now. Go to your variable view. The second purpose is to create a variable that split it. Now go to that filter and change it to low CD4 count. Low CD4 count. You know, you already know that your definition of low CD4 count is less than 200. So, so you can come here, you can cancel out this label. If you leave it, it's labeled that this is CD4 count that is less than 200. But if you don't want to, if you want to leave it better, this is what will be showing you inside when you are running this something. This is what will be showing. But I don't really like it. If you don't want, you can cancel it. No, bring your cursor out. I just click on it at once and call and delete. I just click and click on delete on your computer. Yes. Now come to the value now. Click on the value. So the one that is selected as having CD4 less than 200 is the 1. The one you didn't select is no. So you just say that not selected. 1, change it to yes. Change selected to yes. So you say low CD4 count. Yes, those are the people that have low CD4 count. And change. Now click on here. Click on the other one and put no for not selected. Mark it as no. No, leave it at the 0 like that and mark it as no. Simple, yes. You have created new variable now. CD4 count, yes or no. Just like say skin lesion, low CD4 count, yes or no. Just like say the way you have skin lesion, yes or no. Do you get the low CD4? And you can do it for, that is what they use when they say who is diabetic. They did blood sugar for all of them. Anybody that have greater than or equal to 126, they say diabetic. That's what they use to separate them. Now go and label it diabetes, yes or no. You understand me now? So you use it.
Excellent.
Yeah? Beyond that, a lot of things on this thing. You use the Boolean logic also. You can use that logic, this logic you use now, to select this thing. You can use it to select, okay, let's do some things. We'll come back to that because you can easily, you want us to use the other data set, PMI, to do that one. We'll visit it later because that one has a lot of some function you can use.
How to remove this filter?
Yes, you go back now. Thank you. That's a very good one. Go back to that data. Go back to where it comes from. Select cases.
Then all.
Yes, select cases. Just say all cases. That's all. All cases. Click on all cases. Yes. Say okay. And you see that it has removed the filter, but you have created your variable for you. So that one variable has come to stay. Yes, you'll be saving. You can save Ctrl S and save what you have done. Now, let's run some of this analysis now. Let's run maybe the age group you did and low CD4 count. Want to split it. Let's say we want to split. We want to do it as you have to split 5. You want to do it for male and female. You want to run the analysis for male and female. You want to use sex as a split variable. Go to that data also. That's what we call splitting 5. Go to the data. No, not analyze data.
Data.
Yes, and that's where you are. Now, go to split file before select cases. Third to the last, split file. Notice this split you see in the beginning when you are creating your variable. What is the row? The last option, the last column. In the variable view, when you say what is the row, I say partition, input, split. You can use the same thing, but it's the same thing. You say split. If you look at by default, you say analyze all cases. That's why it's not splitting, it's analyzing all cases. Then I want to do something so that you see the way it works. Click on the last option, organize output by groups. Then move that text, your split variable, move it to the empty space. Yes, click OK. Click OK. Okay, now let's go to analysis now. It has split it, but it will not bring you anything. But the coding may put it, the command that corresponds with what you did. It put it in the output. You can go and read it there. If you see that command, that is what starter they use. They use command, they use and to command. But the SPSS, their graphical user interface is highly developed, is the most developed of all of them. So you can just be point and click. But as you are point and click, the computer is writing the command. Do you get the picture now? But for the starter, it's you that write the command. So now let's go to analyze. Descriptive, statistic, and frequency. Go to frequency under descriptive statistic. Okay. Move that. No. Go down to the thing you just create. Then use that your low CD vocal and age group. Just go and bring them inside. They are the last variable. Yes. I just want to use as a sample. Click OK. So you have to share. Go and share you can stop sharing this one, go and share that one. Because I'm not seeing it. Share your output.
Okay.
So clear.
You can see, Abi?
Yes, I can see. You can see. Can you see? If you scroll down now, expand that thing and be scrolling down, you will see. Can you see male, female? He did it separately. He did each of the analysis for age group. He did this sex. Can you see? He separated them. Sex. And now the under sex male. He did run the two analysis. But you see something now. This is scatter. Come and see a good, better alternative. Now go back to that data. From here, just from here, go to the data. Go back to that split file. Go back to the split file. Then click on the middle, the option in the middle, compare group. Instead of organize something, click on the compare group. Click OK, click OK. Go back to analyze and run from here also. Go back to analyze and run the same thing. Go back to analyze. Frequency. Just say OK. The command is already there. Or they just say OK. Can you see the way it did it now? On the same table, in output male, female, the sex side by side. This is better. You get the vision. I just allow you to go and run the other one so that you know the difference between this and that. So this one is better. So you must just say compare group. Compare group doesn't mean that it's compared statistically. It just say that they put it side by side on the same table for you to see the two groups. So that is how to, number one, split file. So that when you have a barrel, I know you want to really based on a particular variable so that you can do it for different sets of that variable. So that is, any analysis you are doing now, it's not only this one. If you run mean, okay, let's go and do the mean we did yesterday. Let's go to descriptive. Let's look at the mean of age and CD foreground and viral load. Let's go. Go to analyze. You see the way we put this also. Go to analyze descriptive and descriptive, not frequency this time. Descriptive. Move age, CD foreground, and viral load because those are the quantitative variables. You cannot go and if you go and put categorical variable because it will do it for you, but what is the mean is doing is that of the code you put there. You understand me now? Somebody doing a PhD has done the same thing. They mean sex. Calculation means sex in the research. Can you imagine? PhD. And he's a doctor now. Doctor of letter.
You don't mean it.
Oh.
Well, you can't do a mean of sex now.
Yeah, and when you know the computer is garbage in, garbage out. So when you code, like the way you have code as numeric now, they just run. That's PhD. This country. Okay, what are we doing now? Click OK. Click OK. Can you see?
Now click.
Can you see the? Can you see the? Go to the last one. It should be the last output there. Yeah, look at it. You put the side by side, a female, male, because you are speaking. I used to show them. So you know how to split file now. You understand me now? And you know how to collapse quantitative variable. Either you divide into 2 or you divide into more than 2. You have done that one. Then now,
sorry.
Okay.
Sorry, the 95 there is the confidence interval, Abi?
95. Where?
N.
Where is the 95?
N is an N there. Is it
no,
number of
that is sample
cases?
size. No, that is sample size. So here female they are 95, male they are 55. Because the total sample for this is 150. Males are 55, female are 95 in this data set. Don't worry, we are going to see 95 confidence interval now. Now, let's go and explore. We want to explore. They go back to data so that we could now let's return them back. We don't want them to split. We don't want to split it again. So when you don't want to split again, you just say go to split by say analyze all cases. Just say okay. Great. That's it. Now I want us to explore. Go to analyze. Want to explore that age for the shape, for the normality, whatever.
Analyze.
Analyze, descriptive, explore. Down, explore. Yes. Explore. Click on it. Now move age to that box as dependent. Age. Okay, move viral load and CD foreground. CD foreground and viral load.
As factor list.
No, as part of the same. I want to explore 3 of them as independent lists.
As part of dependent. As dependent.
Yes, dependent list, yes. Viral load also. Well, those are the quantitative variable. Click on statistics. Statistics is up. Statistics.
Okay. So I should just say display both statistics.
No, just leave it like that. Click on statistics. Okay, that one there is not even something. Can you see 95 is already there? Is that we are not even good there? Where do you need percentile? Just continue. Yeah, that one is okay. It's okay. The default is okay. Click on plot. Plot. Not that plot.
Okay.
What you see there is not that flow.
It's a display.
You see by default, stem and leaf is check. Check histogram also. You begin to remember why did they check stem and leaf? and they leave histogram out, I will tell you. Because term and leave give more information than histogram. Okay, click on normative plot with text. Click continue. Click OK. Okay, it's coming. It's a bang of many things. So you can see, you can see age, you can see this is the description of age, you can see the confidence interval. You remember the age yesterday, we said the age is skewed to the right because the mean is greater than the median and the mode. Can you see? You see the age now, 33, the median is 32, the confidence interval, 95% confidence of age, 31.99 to 34.441. So scroll down. You see that the CD4 can also 493, and the where is the median? 5. So the CD4 can is skewed to the left. The age is lower, and the mean is lower than the median. Can you see? The mean is lower. That one is skewed to the left. So look at viral load is skewed to the right also. Viral load is 474. Then the median is 255. Can you see? So viral load is skewed to the right. Okay, scroll down. Okay. So I'm seeing we are past. Okay, yes, I've seen it. Normandy with test. These tests, there are 2 tests: Komogoro-Smirnov test, Shapiro-Wilk test. Both of them, the test for level, if you quantify the skewness. So what happens is that there's in the software you are using, there's a data set that is normally distributed, perfectly normally distributed. So you will now compare your own. As you run the analysis, you compare your own data with that one. If there's a statistical significant difference between that one that is perfectly normally distributed and your own, examiner, there will be significant difference. The difference. So that's what we are looking at now. The p-value is the significant here, SIG. Examiner, the SPSS right here as significant p-value. So the p-value for you to see 0, those are people say that maybe decimal place maybe 0.0009 or 0.00035, whatever. And they say it cannot be 0, but it's not true. Since probability can be 0, so if p-value is probability, why can't it be 0? But why we quote it, whenever you see 0 there, you say less than 0.001. That is extremely small. You get the picture now? We put the less than 0.001. So it shows that each of them, they are skewed. They are far from normal because the p-value is less than 0.05. When the p-value is small, that is the probability that the difference you are seeing is by chance is very small. So it's not by chance. So your data set is, or those variables, they are significantly skewed. They are different from normal. That's what it says. And
if it's normal, what will leave with 1?
No, if it is actually normal, the p-value will be close to 1. Yes, if it's perfectly normal, it should be 1. Or when it's 0.9 close to that, should that is normal. So if once the p-value set is greater than 0.05, that should have can say is normally distributed. Now let's go down. Look at go down. Let's look at this graph. Is it skewed or normally distributed?
It's skewed now.
It's skewed to the where?
The mean is on the.
Just join now. Where is it skewed to?
You look at it, it's skewed to the right, too.
Thank you. It's skewed to the right. So that is, that's the age now we saw. The mean is even more than the median, so it's skewed to the right from the shape. Yes. Let's go down. Look at stem and leaf, the next one. It's okay that, yeah, stop that. So don't move away. I want you to show both stem and leaf and the histogram at the same time. I want you so scroll down small so that I can show the. It's okay. It's okay. Now, if we look at these two now, it's the same shape. It's only that the stem and leaf is tilted to one side. It's not sitting on the base like the histogram. And if you look at the shape, it's the same. It's the same shape, perfectly the same. It's actually the same. Since it's the same data, it's the same. So it's skill also. But if you remember when you were checking, when you, I say they've already checked stem and leaf as default. You just check histogram because they didn't check. If you didn't check histogram, if you not run, and the stem and leaf has been checked as a default. Now, why should they even check? Because many people know histogram, what stem and leaf. But stem and leaf give more information than histogram. They are showing the same thing, but the information in the histogram is more. Let me tell you, this thing you are seeing, this stem and leaf, this you see along this way, you see something like, let me
all the values.
What do you say?
No, you know it has one.
Yes. Okay. So what is here is that this one you see frequency, that is one in that category, and that one is less than or equal to 18. Actually, the smallest value there is 18. This one is 1. This one is 19. 19. This one is 1. This is 21. This one is 8. It means 23, 23, 23 in 8 places. So stem and leaf, what it does is it arranges the digit. The last digit is the leaf. The initial digit are the stem. If there are 3 digits, something like height now that has 3 digits, the last digit will be the first 2 digits will be the stem. But because this one now is about age, which you only have 2 figures, 2 digits. So the last one, the second one is the last, is the leaf. The first one is the stem. If it is something that has 3 digits now, the first 2 will be the stem, the last one will be. You get it now. So that 8, the next one, 9 frequency just mean 24, 24, 24, 24, 25, 25, 25, 25. The next one that is 11 is 26, 26, 26, 26, 26, 27, 27, 27, like that. You get the logic now. So, you can actually take your pen and write the 150 values out of this list and go and enter into computer and run it. So whenever somebody, maybe in a journal, he presents stem and leaf, you want you to have access to the data set. You already have access to that data set. I don't know if you understand me now.
Very well. So that 22 means it has 32, about
exactly.
Then 33.
Yes.
Then the 14 is 34 and 35.
Exactly.
Then the 7 is 36.
Yes. All of them,
The 10 under 7 is
in those 7 places. 36 in 7 places. You get to be showing the frequency.
Very
that's
well.
what So you can see that it gives more information than histogram. So scroll down. Scroll down. So this one is what called quartile plot. You know, remember we talk about quartile, the thin quartile, 25%, 10, and 75%. And the 50% happen to be the median also. So I told you there's a software inside the software, their particular distribution that follow normal distribution is there. They are quartile. The computer just plots the quartile with the quartile of your own. If the distribution is the same, if your own is normally distributed like their own, all those points, because each point is where they are expected, is the one in the software. Observe is your own, the one below, observe. Expected, the vertical is the one in software. If the point is where each value meets, value of this one, this value of where they meet is the point. is the point. So if actually it's normally distributed, it's supposed to be online. You know, in a tug of war, if the two sides have the same strength, the thing will be in the line, in the middle. So this is for you to follow the diagonal. If perfectly follow diagonal, if it's normally distributed, the more deviated from diagonal, the more that is skewed. I don't know if you understand me now. Do you get the logic? And if you look at it, it's still more of it is out along the upper part than the lower part. That's especially there's some outlier down, that outlier more outlier up. That's why eventually it's now right, more skewed to the right side. Yes, sir, ma'am. If the outlier, okay, you okay, go down, you will see the one for.
You know,
yes.
The one below. You know the line cut across it.
Yeah.
So as it's going up, the outliers are down.
Yes. But if you look at it now.
These ones are these?
No, when you say below, this is the one on this side, the left side, the one I say the lower value. I'm talking on lower value and upper value of this data set. The upper value, they are off the line more on the upper part. Can you see?
These ones?
No, this upper part. This one, this upper part. Yes. They are more off the line down, the one below here. Oh, you shifted to something. You know, I was drawing you. Okay, no problem. Just.
Oh, sorry. Do it again.
What I'm saying is that this outlier down here, a lower value outlier, I'm not as many as the one up here.
Yes.
That is why eventually it's skewed to the right. So when you see the one for, we're going to see, when you see the one for CD4 can that is skewed to the left, you see, scroll down. We are still doing the one for H. So this one, I don't know what is actually for distended, so that I'm trying to find out what is trying to explain. Trying to explain something, I don't actually know it. Just go down. This is box and whisker. No, don't go. You have moved too far. Box and whisker. There's one you are ahead. It's okay. This box is okay. It's okay. This box and whisker, what it does is it's still the same thing. It's showing the how whether it's normally distributed or not. The box, the upper part of the box correspond with 75 percentile. The middle, the line in the middle correspond with the 50 percentile, which is the median. The lower part of the box correspond with 25 percentile, which is lower quartile.
Okay, we are on top.
So yes.
So you have 44.
What is it?
The middle is 50.
The middle is 50%. 50% is the middle, the line. The middle line, the number,
here.
Yes, that is the middle second quartile. That's 50%. If you remember, the value was 32. Look at it now. Look at it. The value of the median is 32.
Yes. That's somewhere around here.
It's 32. Yes. So that is the median. That is the second quartile. The upper here is 75 percentile. The lower here is 25. Yes, I mean. Then the whisker, because this is the boss, they call it boss and whisker. The lower and upper whisker. The end of the lower whisker is the minimum value. The end of the upper whisker is the maximum value. Okay. Does it make sense? Now,
yes.
But maximum value in the sense of the manageable one, if you look at it, I don't even, okay. This graduation here, what is here? Okay, let's lay down. Now, if this scatter is telling you outlier, you see one here, there's one outlier at the lower value, but we have more outlier at the upper value. That's eventually, that is why it's skewed to the right. You get the picture to the right, because they are more, because they have the higher side is the one to the right. So that's why eventually it's skewed to the right. Now, you will see that No, I explained the cause of positive outlier, extremely high value. The cause of negative outlier, extremely low value yesterday. Now, this value you are seeing here, you see this on 100, this thing. What is just showing here? The position of those outlier in your data set. Depending on the way you have sorted your this thing before you run this analysis. If you want to the highest outlier now is number 100. That's the highest. That is, you know, sometimes when you say, no, it may be by mistake. Where is that value outlier? You want to locate it. Just go to your computer. Its number. It's telling you the number. Okay, you can confirm it. Please stop sharing this and share the other one. Share your data.
That's the position now. That's the position.
That's the position. No, share the something. Okay, you know, okay. That because the highest age is 56. You're going to see that on the numbering on the SPSS down, number 100, that's where the age 56 is. Yeah, it's trying to give you the position. If you want to go and check and track it, that's what that one is just doing. Let's go down. Let's go down.
Okay, let me stop. Let me stop for the benefit of those going to watch it so that they can see it.
Okay, okay. Okay, yes, okay. We have Mr. Adewale is that the thing is not connecting. You are connecting with two. Okay.
No, it's only one.
But
hello.
I think one is connecting also. Another Adewale is connecting. Don't worry.
I used the phone before. And okay, I'm not hearing.
Okay, the phone is still roaming. Don't worry. Just enjoy yourself. You want to share the other one? Somebody send chat.
Okay.
Everyone, okay.
So they can see. They can see.
You can stop sharing your hand. Now share the data editor window.
Okay. Now go to 100.
Go to number 100, the numbering on your, not your number, serial number, the number on the computer. Can you see? That number 100, just click on number 100 on your computer. On this computer, number 100 is here. Just click on it. You see, look at the age. It's 56. That's the highest age.
Okay.
Do you get the picture? So that's the highest age. So
okay.
So it has nothing to do with it has nothing to do with your serial number you enter, but if you sort your serial number before you run it, of course that 100 will correspond with your serial number also in that case.
I know.
But the number on that SPSS that is using. Okay. You can go back so that we continue explaining what we want to get. You can go back. Stop sharing and go and share the viewer window.
Okay.
Share the viewer window. It's not coming. It's not forthcoming. Okay, it has come. Is this you are still sharing?
With the share.
No, it's showing us the.
Is that the viewer window?
No, this is data editor. The viewer window is the result, where that result will the result.
Okay.
Stop. It's taking time. It is single click. You have to double click. Okay, yeah, that's great. So let's scroll down. You can see that this one is negatively skewed. But it's as if it's bimodal. As if it has two modes. This type of distribution, that's what we call bimodal distribution. Hello, can you hear me?
Can you see it?
I've seen it. I said this type of distribution is what we call bimodal. Can you see? Bimodal distribution because it has two peaks. Can you see? Yes, I mean now. It has two peaks. Bimodal distribution.
Euro.
Yes, I'm listening. I'm waiting for you.
I'm back. Oh, okay. Oh, I didn't know that I've not even shared. I thought about it on my screen. But this thing, I could share the whole this thing before now. I could share the whole computer. You know, instead of sharing one.
No, you cannot. Azal. No, you know when you are working with SPSS, sometimes no, it doesn't. SPSS usually give problem. You have to unshare and share again. Usually, if you are working with SPSS, it usually give problem. You will just so you won't be able to. It will collapse one of them. You find it difficult. So it's better if it's the SPSS, just unshare and share. Unlike the other document. Can you see this one now?
Can you see my screen?
No, you have joined. You have joined to viral load, but you have passed CD4. Scroll up first. I want to see the CD4. Okay, it's okay, it's okay. Yeah, scroll down.
By
modal.
And what does that mean?
It means that he picked two times.
I know.
He first of all pick, he pick again. That is bimodal distribution. It has two modes. So let's go down.
But it's not the function of the way it was arranged.
Eh?
Is it not a function of the way it was arranged?
Function of
the way it was arranged.
No. That's nothing to do with arranged here. So just the nature of the something bimodal. Something there's something that do like that. Even in there's one cancer that is bimodal in medicine. Is you see it more among children and also among somebody elderly above 65. Hodgkin lymphoma. Hodgkin lymphoma is bimodal. It peak in two different age groups. So go down. But it's negatively skewed. Just go down. Yeah, you know we have explained all this one. We have explained all this one with age. You can see that the more skewed is to the.
But this one that is above,
above as well.
This one that is on top. Yeah.
What is telling that there are a lot of skewed data below than above, and that's why it's negatively skewed. On the lower side of the data set, we have more skewness than on the upper set. That's why I wanted to even show you. Let's go down.
Okay.
Okay, that's what. That's where you look at the other one is positively skewed. So if you go to the extremely skewed, that's viral load. Extremely skewed. So that is now. How do you, whenever something is skewed? Okay, look at this. Can you see now? This is the something negatively skewed. Can you see? Because the gap between the middle and the one down is higher than because if it's not skewed, it's supposed to be in the middle. That 50% will be in the middle of that this thing. If it's not skewed. So
if I want to use average, now what do I use as average? The median.
It's the median, yes, and because it's skewed, the median is better. Okay. what they call interquartile range is the distance between the box, between the lower and the interquartile range. The difference between 25 and the first and the third quartile. That is interquartile range. That is, so if it is skew, seamless skew, if you plot, you can, if you are plotting that trend, you are saying every year, you can plot the lower quartile, the median, and the upper quartile. See the way it changed over here. I think let's see now. How do we correct for, you were talking on, let's try to do for that age. Let's do, okay, I need to explain something. Just wait. So I want to share something.
Okay, as you on share?
No, if you don't even want to share, I can still share. Okay, stop sharing. Stop sharing.
Okay.
Now, in a situation where there is skewness, what do we do? Like, where I have shared this one, let me just. No. How do we check for now? That's all we have done. But the only thing we did, we did PP percentile plot, because it's not in the option of that explore, but outside the explore, we can do it. You know, instead of this one using quarter, I use percentage 100 instead of the, they are using, instead of the 3 points, is using 99 points. Percentage is 99 points. I divide something to 100 parts. So there is the same logic, it's the same type of graph it gives you. Percentile plot. No, now whenever you are having issue with normality, no, we talk about quantifying it also with all those tests, Orograph, spin-off, and Chaplowicz. Whenever you see something is not normally distributed, what do? There are 2 ways you can, 3 things, options. You can rely the test you want to carry out. You can rely on the robustness of the test and still use parametric tests. But if what is a robust test? A robust test is a test that is still valid when not even all the conditions for using parametric tests are met. Then, like a t-test and ANOVA, they are robust tests. Now, you can decide to say, okay, you want to use non-parametric tests. Instead of using parametric, since it's not normally different, now use non-parametric counterpart. Each of those tests has their own parametric t-test now. We have the Mann-Whitney-Hughes and Wilkinson test. Then for ANOVA, Kuka-Wallis test as parametric counterpart. That's the way it goes like that. Now, or you transform the data into a new set of data that are consistent with the assumption. You now transform the data, you can maybe normal. Now, the transformation, what is the logic behind transformation? So there's something I want to see here also, the logic behind transformation. Imagine if you have, so let's say these are the data set, 1, 2, 3. I'm just even using just serial number 1 to 10. 5, 5, 6, 7, 8, 9, 10. If you are to transform this data set into, let's say you want to transfer them, this one, you want to find square of each of them. This one will be 1, this one will be 4, This one will be
Yeah.
10. This one will be 16.
Yeah.
This one will be 25. This one will be 36. This one will be 47. This one will be 64. This one will be 80, 81. Then 100. You have transformed it. If let's say instead of squaring, you use square root, what the transformation want to do for the x is square root. This one will be 1. This one will be 2, rather 2. This one, that is a square root of 2. And sorry, this one will be 1, is it 2? 1.4, 1.414. That is root 2. That's 1.414. Root 3 is 1. No, is it 1.44? No, it's actually 1.141. Yes, 1.141. That's the root 2. Then root 3 is 1.32. Root 4 is 2. Root 5 is 2 point something. Root 6 is 2 point something. Root 7 is 2 point something. Root 8 is 2 point something. Root 9 is 3. And root 10 is 3 point something. What I just want to establish here is that this original number, the distance between them is 1, 1, 1, 1, 1. But when you square it, as you square it, the distance is increasing. The distance between their square, this and this is 3. Here is 5.
Yeah.
Here is 7, 9, 11, 13, 15, 17, 19. Can you see the difference between them? So as you square, it expanded the distance between the value. That is what square transformation does. The root transformation, it lower the distance. Can you see the original data, the difference between them are 1, 1, but here now is less than 1. 1 and 1.1, and the less than 1. All look at all of them. The distance between them are less than 1. When you find the square root. So what square root does is to bring them closer. Yes, I'm now. Bring their value closer. Where square does is to expand, make them different more. Yes, I'm now. Make them to be different more. So why I'm saying that is the logic. The logic I want to see here.
Yeah.
Then I want to, what is this thing? What is the cursor?
Go to the slideshow. That's why.
And that's why I'm going to the classroom. So look at for then before I come, let's look at log transformation with its own logic. Log transformation, the logic is employed. Is this? You look, this is here, upper part is log of x, lower part is x, which is normal number, ordinary number x, the logarithm here. If you look at it between log minus 1 and 0, is one that is different between them. Then all the log scale by the difference you see is 1, 1, 1, 1 between the log scale. Then look at the distance between the corresponding x. Between log 2 and log 3, the corresponding value is 100 and 1000. The difference is 900. Between log 1 and 2, difference in the corresponding number is 10 and 100. The difference 9 is 90. 900 here, 90 here. Here is 9. Can you see? The 9 between 1 and here is 0.9. And whereas all these things, the distance is becoming, as you are moving, increasing here, but it's constant here. But here, what you can see now, the log, look at this is negative value here. What is given here? What it does, logarithm does is bigger number. It will bring it down, collapse bigger number, and stretch small number. It's just like maybe the rich people you collect money from them. You reduce their way, the poor people, you give them more money. You understand me? That's what log does. It brings down bigger number values and stretch out to expand smaller one. That is what log does. And if you look at the table now, the recommendation, if something is skewed to the right, positively skewed, then the recommended solution can use log transformation or reciprocal or square root. If you look at it, when something that, you know that positive skewness is an extreme outlier, a bigger value that is extremely bigger than the rest. Yes, I'm now. So they are looking for something that will slash it down to come and meet the rest. That is why log and or reciprocal, because reciprocal make the bigger to be smaller and the smaller is the biggest. That is because reciprocal is 1 over that number. Now square root, we have seen the way square root did here. Now, if it is positive, negative skewness, is power transformation square. You know that for negative skewness is extreme outlier that is small. So what if you square the square, we jack it up. That is why we do square transformation. Let's go and do log transformation now. So share your data. Let's do share. Share that thing, particularly the one we are using. Now share it.
Okay.
Yes. Share the better share the result view so that we won't be sharing 2 times. Share the result view in hand. Because you can access those functions from there also. Go to transform. This one also is transform. So that transform.
Okay, transform.
There's one compute variable. That first one, compute variable. Now, what you want to compute target variable, you want to do log age. Because age you want to transform log age. Type log age there. Type log age in that space.
Yeah.
Remove it from there. Remove that set. So remove that set.
Okay.
No, you can remove by just deleting it. Delete it. Delete it. Just backspace and delete it. And delete. So that space there, target variable, type log age. Are you with me?
Age or log age.
Log age, yes, log age. That's what you are aiming at. That's one name of target variable. So the space here now, that's where you want to put the expression. You know, you're under compute. When you are under compute like that, what you want to compute, you first of all say it. Then that is equal to. So you will see, come to under function group. If you click all, don't click all here. If you click all, it just show all the function. You will not begin to look for searching for what you're looking for. But if you click the group it belongs to arithmetic. Logarithm belongs to arithmetic. Click on arithmetic. See the form. Immediately you click and it select those arithmetic. So go to natural log, ln. No, you don't need to square. He was looking at you. ln. Yes, that's natural logarithm. So immediately you do that, you mark this place. And you now move natural logarithm of what? Can you see? So what you do now?
Yeah.
You know, you did something you yourself didn't know. Because immediately you click on this thing. Is it that you double click on it? You know, because you need to actually, when you select, once it is when you move this thing that it didn't move up. Maybe you double click, that's why you move up. If you didn't double click, you have to now click on this one to move on. Now you now click on age. Click on age now. Now just move it to replace that question mark. Great. Click OK. You have done. Click OK. Yes, you have done it. So when you see how to go and share anyway, go to Okay, unshare this one, share your data editor window. You're going to see where he put everything.
You said I should do what now?
Unshare, stop
Go
sharing.
down.
Stop sharing, stop sharing.
Okay.
No. Stop sharing and share the data editor window.
Okay. That's the output now.
Yes. No, it's not output. Maybe it's output you unshare and the data editor where we usually put the data.
Oh.
Data editor.
Yeah, I know. I'm gonna share one back.
Share.
Okay.
You can't see share again.
What's the
You are still sharing the same thing. You are still sharing. Okay, we have seen it now. So, can you
If
see
you share screen, if you share screen, you can change screen without sharing.
You can
Really,
share.
if you look,
How do you do it?
you will see screen. Once you see screen, click on screen. Don't click on the Windows. You will see screen, and it contains our Zoom IDs.
Okay.
Click on that one, then you can.
Is it not that in the share screen you see the screen also? I know what you are saying. I know. If you go back to share again, you will see all those things will be there. You see the screen. You double click better. The SPSS is giving. I know that one I do it, but the SPSS is usually give problem in that sense. If you want to change to the other one, when you play, it collapse one to the other side, and you'll be confused. So it's for if you want to change screen between SPSS, it's better you sometimes or not all the time. You double share. In fact, if you want to share again when that one is still on, you don't want to stop sharing. It will know you'll be struggling with it. That's what is happening because I've seen it like that. That one you are talking, I know, because I will just do that. Okay.
This is fantastic. It has made it normal distribution now.
And can you see the log transformation now? Can you see? Look at the log is the last variable now. Look at log.
So in other words, if you do a mean of this log age, right? The corresponding number can be served as the mean.
No, it's not the mean. Can't you see the value now? Can't you see age now? It's giving you 3 point something. Why your age are in 50, so 5, 50, 60.
What I'm saying is, I understand. What I'm saying is this, right? That the corresponding value, you can't work with this one now.
Okay,
this is normal
I will
distribution.
say something about that one. If you calculate the corresponding, what you see, the log of this is what corresponds. But when you calculate the mean of the log now, it does not give you now anti-log. If you calculate the mean of this log now, when you do the anti-log, it's not equal to the mean of the original value. It will be equal to the median of the original value. And the mean is a geometric mean, it's not arithmetic mean.
Okay, so in other words, in short form, that when it is skewed, the average becomes the median.
Yes, that's exactly what is right. I would say so. So let's go back to explore now. Let's explore it to see the shape. Go back to that analyze, descriptive, explore, and let's look at the shape. Let's explore this log age. Remove all those age and this thing you put there. Remove and put log age. That's the last thing. Click OK.
Explore?
No, click OK. Because the last operation is already there. I don't know if you understand me. All this thing you are click on it work. for it. Can you see
Look
now?
at it now.
Can you see it's better than the other one?
100 million times.
So that's just the logic. And look at the other one, so the bus leaf. Leaf. Can you see? So go and look at all those other ones, bugs and this thing. So it's better. Though it is skill also, but it's better. I made some correction. That's the logic for log transformation. But it's the last option you use because the life is not the same. So interpreting is a big problem. Examiner. So that's just it. That's
so you're not advised to use.
It's not easy to use because just like the way it's a different scale. Examiner. It's logarithm scale. It's a different scale. So actually, what is the last option?
How does chi-square come into this?
How can
chi-square come into this conversation?
Did you see chi-square anyway?
No, I'm just asking because I thought you use chi-square to determine the mean in a skewed distribution.
Well, you believe well.
I'm not asking.
You know why I cannot say. You know why I cannot say no, eh? Chi-square generally you have. In fact, chi-square, if it's not more than 100 things that even follow chi-square distribution, because it's the one we know and you keep on discovering more and more and more. But majorly, most of the time, the common chi-square we use to compare categorical, look for association between categorical variables. If that has something to do with the mean or bet, what you have just said, whenever you are comparing quantitative variable and is now skewed, you use non-parametric test. Chi-square is one of the non-parametric tests, but this other one you use, there are many of them, but sometimes also some of them they are called chi-square, but it's not the chi-square you know. They are different types. They are like Krukawali's test, which is the non-parametric counterpart of ANOVA. It follows the chi-square. What statistic you use in logistic regression is a chi-square. There are many things that are chi-square. The median test, which is non-parametric counterpart of both ANOVA and independent t-test.
What does the ANOVA do?
You're comparing mean of more than 2 groups, 3 or more groups. ANOVA.
Okay.
Yeah. So I think maybe we should just stop here. Tomorrow we finalize. That tomorrow we'll be using the other data, that BMI data that we're going to use. So we're going to do some further how to compute BMI, then how to do some Boolean logic. Do that.
Okay.
In selection, in those concepts come from probability. We look at it tomorrow to use this thing. That's just it. So this is just for you to.
Any question? Debo, any questions?
Because I came late, at least I'm trying to catch up. But at least it's recorded now, so I can play back and see.
Yes, it's recorded.
Maybe I will have some questions concerning it tomorrow. Especially this last part. I don't know where you the bimodal and this last one, this log age distribution
transformation.
Okay, I don't know what.
Okay, maybe you go and play. When you play tomorrow, you ask question because I'm going to link it to you. I will go to send you the link also. I will do that.
Okay.
So you can ask question tomorrow.
Okay, thank you.
Welcome. Thank you. Okay, Chief Emeka2.
Okay, already.
You're welcome.
You can shut down
Okay, thank you.
as the host.
Thank you.
Yeah.